Okay, this will be a brief summary of the Chapter 13, Section 5 Colligative Properties notes that we cover in AP Chemistry. The first thing is the definition of a colligative property. A colligative property is basically a property that changes depending on how much solute is dissolved in a solvent. One such property is the boiling point of a solution. Whenever you add a solute, let's say sugar or salt, into a solvent, such as water, it's going to reduce the ability of the molecules to escape the liquid and turn into a gas. So the boiling point is always going to be higher than before. So basically the vapor pressure of the solvent is lowered. Therefore it's going to boil at a higher temperature. So if you had sugar water, it's always going to boil at a temperature above 100 degrees. And again, the reason is that it lowers the vapor pressure, and so the water molecules that would typically go from the liquid state to the gas state can't at a temperature of 100. They have to have more energy to escape the liquid, and so it has to be above 100 degrees. And here's a picture of a pure solvent on the left having a certain amount of vapor pressure, and then when you have a solute added to the solvent, you can see that the vapor pressure is lowered. And then if you wanted to calculate the boiling points of a solution, you have to calculate something called molality, which is the number of moles of the solute divided by the kilograms of the solvent. And you have to also know if the substance breaks apart into ions, and so if it's an ionic compound, the number of ions that are in the solution will affect the boiling point. So if you had something like sugar, which is a molecule, it just stays as one sugar particle when it dissolves. But a substance like table salt has one sodium ion and one chlorine ion, so it would affect the boiling point more than if it were just to stay together as a sodium chloride particle. And so in our formula we have the letter I, which is added to our formula to calculate the change in temperature of the boiling point. And I is the number of ions that a substance breaks apart into. Kb is a constant, which is called the boiling point elevation constant, and it just depends on the solvent that you're dealing with. And m, the lowercase cursive m, is the molality of the solution, and again I is the number of particles that it breaks apart into. So I show as an example table salt, which is NaCl. It only has 2 ions, but something like calcium chloride actually breaks apart into 3 ions. And sugar and other molecular non-electrolytes do not break into ions, so their I value would just be 1. If you wanted to calculate the freezing point of a solution, you basically are going to be doing the same formula, but here's the reason that freezing points are lowered whenever you add a solute into a solvent. So basically what happens is that the solute will get in the way of the solid bonds forming, or the bonds that are going to be formed to make a solid crystal. And so if the solute's in the way, it cannot freeze at a normal freezing point. It has to actually get colder before it can make those intermolecular bonds. So the liquid can't form a solid particle, so the freezing point is going to be lowered. So for example, if you have sugar dissolved in water, the sugar gets in the way of the hydrogen bonds that the water is trying to make, and so it's going to freeze at a temperature lower than 0. And I basically explained that 2 seconds ago. Now if you want to calculate the freezing point, use the same formula, except that it's called the freezing point depression constant, which is Kf. And again, Kf changes depending on the nature of the liquid. Here's some constants that we use in class. We have the Kb value for water and the Kf value for water. There are other Kb and Kf values for different liquids, and they're usually used in the practice problems in class and in the homework. But I'll always give you the Kb and the Kf values if you ever need them. So we're going to practice one right now. So we have 135 grams of glucose, which has a molecular weight of 180 grams per mole, and you're going to dissolve it in 750 grams of water, and we're going to calculate the new freezing point and the new boiling point. First thing you need to do is figure out how many moles of glucose there are, and there's 0.75 moles. Then you have to figure out what the molality of the solution is, so you take the moles of the glucose divided by the kilograms of water, and you can take the 750 grams and divide by 1,000 to get 0.75 kilograms. So the molality of the solution is exactly 1, and then you plug that number into our formula to calculate the change in the temperature of the freezing point. The Kf value for water is 1.86 degrees Celsius per molal, and that's the constant which is on the previous slide. And then you have a 1 molal solution, and since sugar is a molecule, it just stays as that one particle in the solution, so I is 1, and so the change in the temperature of the freezing point is 1.86 degrees Celsius. So our new freezing point is going to be negative 1.86 degrees Celsius because the old freezing point was 0. And if you wanted to calculate the boiling point, you go through the same rigmarole, and you end up getting 0.51 degrees Celsius for the change in the temperature of the boiling point. So it's going to boil at a temperature of 0.51 degrees higher than the old boiling point, which is at 100. So the new boiling point is 100.51 degrees Celsius. And we do a lab for this particular chapter where we have freezing points calculated, and we even calculate the molecular weight of the substance of the solute. So there's a lab that is also talked about in this lab, or in this chapter. So it's a pretty short chapter, and it's usually added to chapter 11, and I give a test over both chapter 11 and section 13.5. So that's basically a summary of the notes that we do.